Homework 3.2, Polynomial Functions, Video 10. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. The following example correlates to homework questions 10 through 14, and this is example 5. I do want to say that for the last 3 videos, we're using the functions that were already factored. Checking odd, even, or neither with factored functions, it's not impossible, it's just not as obvious as if they were unfactored. But I will tell you right now, in your homework, when you are graphing a function that is already factored, it is not going to have any symmetries. So you can assume neither on your homework if the function is already factored. Now don't get me wrong, there are factored functions that are either odd or even, but ours will be neither. It will save us some time here also. Also in previous videos, we determined that the end behavior for this function was the left rises and the right falls. So let's go ahead and capture that over here. Left rises, so an arrow up here, and the right falls, so arrow down there. This was a third-degree polynomial, which we discovered upon locating the leading term earlier. So it can turn at most 2 times. As I already mentioned, our factored functions graphs will not have any symmetry, so we can just assume neither. Now we do have to work to calculate the the y-intercept, because it's factored, the terms just don't vanish when I substitute 0, but it's not that bad. We have -2, putting a 0 here gives us 3, putting a 0 here gives us -1. So we just have to multiply -2 times 3 times -1 squared. -1 squared is 1, times 3 is 3, times -2 is -6. Our x-intercepts were at -3 where it crossed, and at 1 where it touched and turned. Easy to recover from here. Since it's already factored, we can see the multiplicities where the powers are. So what would this graph look like? Let's start with the y-intercept. 6 isn't that hard to find. Or -6, I should say. At -3, the graph will cross, so we'll put a C there for cross, and at 1, the graph will touch and turn. So we must start high, cross, hit the y-intercept, touch and turn, and then come back down. Based on what I personally know about third-degree polynomial functions, I know this is going to dip down before it crosses here. But without further information, you can just touch it and turn at the y-intercept if you like. By the way, every third-degree polynomial's graph does have a rotational symmetry, just not at the origin. Somewhere in here is a point where you can rotate this 180 degrees. But the end behavior is correct. It did turn 2 times. It doesn't have y-axis or origin symmetry. And we have the correct intercepts and crossing and touching, turning behavior. So again, once you get all the information, these are pretty fast. I could have probably done more than one in a single video, but I wanted to dedicate a video to each function.